My name is Gustavo, and today I'm talk about to water use efficiency over agriculture and grassland in subtropical Brazil. Um, the water use efficient is defined as the loss of water by plants in exchange for carbon gain during the photosynthesis. To obtain the water use efficient, you need the carbon dioxide flux, the net ecosystem exchange, and the evapotranspiration, which can be use the Eddy Covariance methodology. NE is partition from gross primary production, which is the carbon absorbed by photosynthesis, and ecosystem respiration. In agriculture, the evapotranspiration is essential for the correct planning of water management practice, adjustment of irrigation system crops, and productivity planning. The taste composes of two processes: transpiration from plants and evaporation of water deposited on the surface of soil and plants or plants. The evapotranspiration is a physical process which consisted in transformation of water contained on surface from the liquid to a gaseous state through the absorption of energy from the system and transferred for the atmosphere by the diffusion process. We defined water evaporation as the sum of the evaporation of water contained in the soil process, porous, water contained by the dosel, and water dammed over the soil. The transpiration is a continuous process which comprises the absorption of water from the soil by the roots, transports through the xylem of the stomata that open to absorb CO2 by photosynthesis. Uh, this process depends on the hydraulic conductivities and water potential of the plants and soil. Furthermore, on the leaf atmosphere interface, the transpiration is governed by atmospheric demand, having a biologic control through the stomatal conductance. Uh, we were able to estimate of evapotranspiration and CO2 flux using the Eddy Covariance method. To calculate the water use efficient, you need to partition the ET between evaporation and transpiration, and the NE between respiration and gross primary production. Studies that partition the AT using Eddy Covariance measurements based on the common concept, the facts that the plants, when carrying out the photosynthesis, must open its stomata from the entry of CO2 and the exit of O2 resulting from photosynthesis. However, once the stomata are open, the loss of water to the atmosphere occurs in parallel to this exchange, since the internal concentration of water in the stomatal cavity and higher than the external concentration. Based on this relationship, we can assume that plant water loss is associated with photosynthesis, and using the water use efficiency concept in this study, we evaluate the evaporation and transpiration components using CO2 and flux obtained by Eddy Covariance in a succession of crops, wheat and soybean, and in a natural grassland in the subtropical region. Uh, the sites in the site studies in the grassland in Santa Maria. This area is in the UFSM, and the agriculture area is in Carazinho City. The soybeans are cultivated in summer and wheat in the winter. For for use this technique, the covariance technique, you need the sensor, the high the high frequency sensors for for wind and temperature measurement, and the CO2 and water concentration. The Eddy Covariance method was used to estimate the CO2 and soil heat flux, uh, sorry, and latent heat flux and sensible heat flux. The flux partition, the NE flux partition, represent the difference between the gross primary production and ecosystem respiration. This partition of NE between GPP and respiration was performed using the REDPROC package. To estimate the partition of ET into evaporation and transpiration, use the minimum product between the GPP and the potential water use efficiency by the canopy. This relation, the potential water use efficiency, uh,
2 minutes.
This this relation, the water, sorry, the water use efficiency, the carbon and the C and key indicate a half concentration of CO2 and water. The E and I represent the internal concentration in the stomatal and external concentration. Water use efficiency, ecosystem water use efficiency, the relation to GPP and ET, and crop use efficiency relationship to GPP and transpiration. From agriculture, wheat and soybean periods, the evaporation general increasing during fallow and senescence periods. During the soybean and wheat season, we clearly see that GPP and transpiration and decreasing together this period. The GPP and transpiration increase with plant development and decrease as plants enter a period of senescence. in general, the evaporation is higher than transpiration when the end of the crop and in the first days after planting. And the Pampa results, the evaporation remains a low throughout the year with seasonality. The GPP and the transpiration are higher in spring and summer, and the respiration is higher in summer. Uh, During the harvest, the highest values of water use efficiency are greater than 4 grams the CO2 by kilograms of water, and 80% from ET is the transpiration. When the water use efficient is smaller, the transpiration represents about 20% of ET. Um, when you decrease the soil water content, you decrease the water use efficiency. And for Santa Maria site, the relation T AT ratio is over 70% of interior period. The lower water use efficiency occur in the winter, and water use efficient crop and ecosystem are very similar in the Pampa and show a little variation in the year.